A glass of water, a glass of air. They may seem like chalk and cheese, but in some ways, water and air are very, very similar. Water is, of course, a liquid, and air is a collection of gases, but both liquids and gases are fluids. Fluids are substances that have no fixed shape. Apply a force and they flow, taking on the shape of the container that, well, contains them. However, liquids and gases respond very differently when you attempt to squeeze them, when you put them under pressure. In that regard, they really are chalk and cheese. Cheese. Chalky. Let's explore. A tube filled with air. If I place a finger over the end of this tube so that no air can get in and no air can get out, and then push down on the plunger, well, will I be able to squash the air inside the tube? What do you reckon? I'll give you a few moments to have a little think. Let's give it a go, shall we? And yes, gases are easy to squash. Although most people tend to think, no, you can't squash gases, so definitely don't feel bad if that's what you thought. Now let's try that experiment again. However, this time we're going to swap out the air for some water. Once again, one finger over the end of the tube so that no water can get out. If I then push down on the plunger, well, will I be able to squash the water inside the tube? What do you reckon? I'll give you a few moments to have a think. Let's give it a go, shall we? Well, that answers that question with a great big no. Whoa, whoopsie. Now, just because I couldn't squash the water in this tube, that doesn't mean that it's impossible to squash the water. Water can be squashed, a little. But to do this, you're going to need enormous forces, and we'll get to those forces in just a moment. Both gases and liquids are made up of tiny particles, atoms and molecules. In gases, these particles are spread a long way apart. As such, it's really easy to squash them closer together. In a liquid, such as water, the particles are already very close together. As such, it's much harder to push them closer together. We are at the bottom of an ocean of air. We don't really think about air as weighing anything, but it does. The pressure exerted by the weight of the air in the ocean above us is called atmospheric pressure. Climb higher into the atmosphere and that pressure decreases with less and less air above us. Of course, there's another ocean, that is the actual ocean. Dive in and you'll instantly feel water pressing against you. The deeper you dive, the greater that pressure will become, with more and more water above you weighing down. Now, this tube is filled with water. Down the side of the tube are a whole stack of holes currently covered up with a little tape. Of course, remove that tape and the water will start spilling out. The question is, will the water squirt furthest from the top hole or from the bottom hole? I'll give you a few moments to think about your answer. So, what do you reckon? As I'm sure you all pretty much guessed, the water squirts furthest from the bottom hole. Of course, this is where the pressure is the greatest, with the most amount of water weighing down from above. The deepest known part of the ocean is called the Challenger Deep. It's located at the southern end of the Mariana Trench in the Western Pacific Ocean, and it's approximately 10,920 meters deep. The pressure at this depth is roughly 1,071 times greater than the pressure of the atmosphere at sea level. Because this pressure is so immense, the water molecules are pushed a little bit closer together. That is, the water gets a little denser, about 4.96% denser than water at the surface. It's thicker or more viscous, like honey. Of course, it doesn't actually turn into honey, it just gets a little thicker like honey. Although, how awesome would that be? Just imagine diving for honey. Sweet! Anyway, my point is, gases are easy to squash, liquids are a lot harder. However, as well as being fluids, gases and liquids are similar in one other very important way. Pressure in fluids, in both liquids and gases, acts in all directions. Dive into water and you'll feel that water pressing against you from every direction. The air around us also presses in from every direction. This can be quite a hard idea to wrap the thinky bits of your brain around, but a little demonstration might help. So, I'm just going to pour a glass of water and then place this plastic plate over the top. Now, at sea level, the atmosphere exerts about 1.03 kilograms of force per centimetre on all objects from every direction. So for every centimetre of plastic plate above the water in this glass, there is the equivalent of about a 1 litre carton of milk pressing down. Tip the glass and the plate upside down and that force will still press on the plate, up and from underneath. Take my hand away and the plate should stay in place. Should. And because I trust the science, I'm going to do that over my head. And there you have it. Pressure in a fluid acts in all directions. Of course, there is some other science at play here, and this is a very delicate balancing act. One small wibble or... Don't forget to hit like and subscribe on our YouTube channel, plus visit our website and social media sites for more information and activities.